So this is question 5 from exercise 10F from the first year mechanics book, and it's an exam style question. So we've got a box of mass 2.5 kilograms resting on a rough horizontal surface. So friction will be involved somewhere in our calculations. A light inextensible string. So the acceleration of P to the right will be the same as the acceleration of Q downwards. A smooth pulley, so no friction on the pulley. And then we've got the mass of Q is 1.5 kilograms. And we're just told the frictional force is K. So at some point, 8.3, we're going to have to find K. And the system is released from rest. So the first thing we need to find is the acceleration. So you might start with a force diagram. We're actually going to need to use SUVAT to answer part A, but that might not be immediately obvious. So if if we draw the force diagram and then realise we don't need it just yet, there's no harm done. So let's draw it out. Okay, so what have I got? So there's the friction force. So this is P. There's a friction force that they just tell us is K newtons, and there's going to be tension in the string that's going to pull P along. Then we've got Q here. Q has a weight of 1.5 G, and then there will also be tension. And because the string is light and the pulley is smooth, so there's no friction, those two values of tension will be the same. So if I started using F equals ma, I've got too many unknowns because I'm going to have, so I know that Q is going to move down with an acceleration, and that because the string is inextensible, P is going to move to the right with the same acceleration. But if I did F equals ma, I would have, for Q, I would have 1.5 G minus T equals 1.5 A. So I would have A and T that I don't know. For P, I would have T minus K is 2.5 A, and then there's 3 unknowns. So I'd have 2 equations and 3 unknowns. So, but I will need to come back to that later on anyway. So if that's how you started the question, it really doesn't matter. But to actually get an answer for part A, it's this information I need. So after release, Q descends a distance of 0.8 meters in 0.75 seconds. So easily missed, just that one short sentence, but that's really all the information we need because it's released from rest. So the initial velocity is 0. I'm going to take, so I'm looking at Q, and I'm going to take down as positive. So if down is positive, then S is positive 0.8, T is 0.75, and I am trying to find the acceleration. So I'm going to use S equals UT plus a half a T squared. So S is 0.8, U is 0, so UT is 0. Equals a half times A, which I'm trying to find, times T squared. So 0.75 squared times 0.5 is 9/32. So A is going to be 0.8 divided by that, and I get 2.84 meters a second squared for the acceleration. Okay, right, so back to the question. Right, show that the tension in the string is 10.4. So that's handy because we're going to use our answer to 1. So if we get 10.4 as our answer, we'll know that we've got 1 correct. Do need to be careful with show that questions though, that you do actually clearly show how you've got that answer. So okay. So yeah, so this is where I would need my force diagram. So I've already drawn kind of my overall one. So I'm just going to look at P and Q separately now. So just looking at P, it's being pulled along by tension T. It's being held up by this friction force that we are going to find, and they're both in newtons. And it's going to be moving to the right with an acceleration, and that acceleration will be the one we just found, so 2.84. Okay, and then if I look at Q, so that's P, so So if I look at Q, that's got the tension working up, it's got its own weight working down. That's going to be moving downwards again with an acceleration of 2.84. So if I use F equals ma on P, and I'm going to take to the right as positive because that's the direction it's moving in. So the result of force to the right is going to be T minus K, and that's going to equal its mass, which was 2.5 kilograms, times A. If I look at Q, I'm sorry, I should have labelled this as A part 2 we're answering here. So if I look at Q and I use F equals ma and it's moving down, so I'm going to take down as positive. So it's going to be 1.5 g minus T is mass, which is 1.5 times acceleration. So I've actually done some stuff I didn't need there because I can just use this equation to find T, because I know that G is 9.8, I know that A is 2.84, so I can just rearrange that to find T. So if I do 1.5 times 9.8, and then I minus 1.5 times 2.84, I get 10.44, and then T over to the right-hand side. So just make sure your final answer is rounded to 2 or 3 significant figures and that you include the units. So 10.4 newtons, and find the value of K. Right, so actually this is going to follow on from the working I've done above, because now I know that T is 10.4. So I'm just following on from this equation here. A, I already knew was 2.84, so that's going to let me find K. Oh, sorry, I forgot actually. Sorry, I forgot the part. Sorry, I also forgot to switch screens. That doesn't help. Okay, so yeah, so actually going back to part 2 though, that was a show that question. Move that out of the way. Right, that was a show that question. So I'm just going to add as required there. And yeah, so going on to part 3. So for part 3, I'm just using this equation that I'd already worked out. So I now know T, so I can find K. So if I do 10.4 minus 2.5 times 2.84, and then add K over, that is going to give me 10.4 times 2.5 times 2.84, minus 2.5 times 2.84 gives me 3.3. Okay, let's just check those answers. Yep. Also, yeah, and it should, I certainly should have put 3.3 newtons there. Right, okay, and then just going back, so not to show you the answer, but so state in your calculations how you've used the information the string is inextensible. So they've asked that a lot throughout this exercise. It's a common question. So we used it when we said that they were both moving with the same acceleration. Yeah, so inextensible means it doesn't stretch, so they're moving same acceleration, same velocity if it's relevant. Yeah, like I said, very, very common question.